I also see that you've got a blender over there. I'm getting kind of thirsty all this work. Maybe you can make us a drink.
Okay, I'm gonna make drinks for you guys. Just let me know when to pedal.
Oh, you just hold on a sec. Okay, you go ahead and go. This looks great. Good work, Rosa. Would you like some?
Love some.
All right, here you go. Yeah, that just looks really good. How is it?
Wonderful.
Oh, wow. I don't think I'm going to have any, but I'm glad you like it.
What? You're the one who asked for it.
Yeah, but I changed my mind, you know? Just not very thirsty anymore. Lee, thank you so much for all of your help. This has been really informative. Thanks.
Yes,
Rosa,
thank you so much.
How are you feeling?
Well, I want some food.
Yeah?
Yes.
That's a lot like fuel. I think we can show you something about fuel.
Okay.
You want to see?
Let's go.
All right. Hi, guys. Hi. I'm here to show you a demonstration about fuel. How many of you guys have been to a gas station before? Raise your hands. Okay, very cool. How many of you guys have been to a gas station when it costs less than $4 for a gallon of gas? How about less than $3? Less than $2? I don't think so. Less than $1 for a gallon of gas? Okay, I believe over here. And just out of curiosity, what is the least amount of money anyone here has paid for a gallon of gasoline? Yes?
33 cents a gallon.
33 cents a gallon. Wow. Those days are far gone. So when you're at a gas station, we are there because we need energy, the energy to drive our cars and move things around, and that is a fuel. Now there are signs all over a gas station saying do not do what? Smoke. No smoking at gas stations. We shouldn't smoke in general because it's just a bad habit. But no smoking at gas stations because why?
Because it'll make a big fire.
It could be a very big fire. The way we get energy from fuel is by burning it for combustion. So here's what I'm going to do. I'm going to take something that is like fuel. This is not really automobile fuel. I'm going to pour some in here, this clear liquid, and I'm going to start shaking it up. Now, as I shake this up, I'm encouraging it to evaporate. So it's changing from a liquid into a gas. Very good. It's turning from a liquid to a gas. Now, as this liquid turns into a gas, it's filling the entire space. Now, what I'm going to do is introduce a little bit of energy, just enough to get us the energy back out of this fuel. This is how we actually get energy from fuel. Okay? So here's what I'm going to do. I'm going to dump out the extra. Now, I hope not. Here's what we're going to do. I'm going to push all these things to the side. Now we're going to do this part with the lights out. There is something to see and there's something to hear, so make sure we're all absolutely quiet. So we can get all the lights out that we can. Okay, I'm going to do it again. Ready? 3, 2, 1. Okay, we can turn the lights back on. This is a small-scale version of what can happen if someone is silly enough to light a cigarette at a gas station. Most gas stations are much bigger than this, so the reaction would be much bigger. But here's the thing to remember. The way we get our energy from that fuel is by introducing a spark. That's what our cars do. That fuel is a form of energy for us, and that's what we're getting out of here.
Wow, that was pretty incredible. I mean, you never actually think of it. All that power requires fuel, right?
Yeah, and when we're talking about bikers, that power is like food. However, to make electricity for a city or a town, now we're going to need a larger generator and a much more powerful fuel source.
Yeah.
Well, and it's also still going to work like the bike generator we saw today, just on a much larger scale, you know?
And when you think about the size of the city, it must be.
Yeah. So why don't we check out and see how one works, go see a power plant in action.
Okay.
The way power plants work is generally like this. First, water in a reservoir gets heated to make steam, which requires fuel. That steam is forced from the reservoir over a turbine. The turbine is basically a large coil inside a magnetic field. As the steam goes over the turbine, it causes it to turn. So a coil inside a magnetic field generates electric current, which gets pushed through a series of transformers and transmission lines into our homes and our appliances. So a coil moving in a magnetic field produces electric current, which goes through a series of transformers and transmission lines into our homes and appliances. But the trick is heating the water. See, that requires fuel, like petroleum, coal or natural gas, all of which are fossil fuels. Nuclear sources can be used as well. Now the thing is, it's easy to think that if you're using electronic devices that you're not burning fossil fuels. Unfortunately, that's not the case, at least not directly. See, depending on where you live, your energy comes from a number of sources. Fossil fuels get burned to produce the energy to heat water, and that also produces carbon dioxide. Nuclear sources don't get burned, but they produce a different kind of waste. So the question becomes, what's used to make your electricity?
What is your name, first?
Gabriel.
Gabriel. What type of fuel is used to make your electricity?
Nuclear. What was it?
I am actually not sure.
The nuclear.
I was actually gonna say fossil fuels.
Yeah, that's what it makes. That's what it makes for electricity to make.
I think coal is used to make electricity.
It is nuclear energy.
So can you tell us how a power plant works in general?
Well, what we do here is we burn coal to boil water to make steam. The steam enters a turbine and turns the turbine, and at the end of the turbine is a generator. And it turns the shaft of the generator, and there's a magnet on the end of that shaft, and that's what makes electricity, is a rotating magnetic field inside of electric field.
So you have a rotating magnet, and all of this is done to rotate a large magnet.
That's all it's done. You'll see acres of equipment and material. And
yeah, looks like we're surrounded by acres of equipment right here.
Yes, sir.
Perfect.
We're in the control room right now, and this is a location where all of those facets are being managed and operated by.
Okay.
At some point of its operation within a day, it's an automatic after it's online, and the operator is usually our most experienced person here at the plant, and they take action to act quickly and promptly when things are in alarm.
So this whole process starts with coal, right?
Exactly. This is where coal enters the process to be ground up in a mill below us. What we have here is a feeder, and the feeder rate is set by what our megawatt output demand is. We can open the feeder here to see the coal as it travels from the bunker down to the mill. And the coal comes from western states, Powder River Basin coal. And what we do is below us we'll see the mill where we grind it to baby powder consistency so that we get complete combustion of the coal process. It's almost like miles per gallon in your car.
Right.
You want to get every bit of energy out of the coal.
What are we looking at here?
This is where the coal comes down from the feeder, comes into one of these 8 grinding mills. And these grinding mills grind the coal to a consistency that produces good combustion. And here we can control sizing.
It's like a big pepper mill. It's just grinding and grinding continually.
The big pepper mill, it's run by a motor below us, and that motor also takes the coal, and when it's to the right size, blows the coal up into the furnace just prior to combustion. The output of the mills come through these pipes here and get blown into the furnace. Above us is where combustion occurs in the boiler. The boiler's about 20 stories tall, and we're at the lowest levels. Here is a look at the boiler underneath the fireball.
Oh, wow.
It's a lot of energy to make a lot of megawatts.
Oh my gosh.
We take the heat off of the coal after it's burning and boils water in the boiler. When the water's boiled, it turns to steam, and the steam is what turns the turbine. So we'll see those processes next.
This is for boiling water.
This is a big tea kettle.
Wow.
A 20-story tall tea kettle. However, we keep a lid on the tea kettle and keep it 2,000 pounds pressure and 1,050 degrees in temperature.
1,050 degrees?
Yes.
Oh my God.
We have a lot of auxiliary equipment here that's required to make power.
Okay.
And some of the systems move air. We saw a piece of equipment used to grind coal. This piece of equipment here is a motor that runs a transmission that actually runs a pump.
Okay, so a motor, transmission,
and a pump, okay?
Okay.
And what happens is as load changes, all of these systems you see have to act in automatic to match the load change that the customer uses.
And all that's controlled in the control room?
All that's controlled in the control room while they're on manual. This is a combined control room where the operator has control over the switch yard to synchronize the unit, the turbine and the boiler to actually operate at a megawatt limit that's called for by the system. And so puts equipment on, takes equipment off. This is the turbine gauge board. And behind me here is the boiler gauge board where mills, feeders are controlled.